Welcome to Trotec's webinar series, third Thursday. My name is David Stevens. I'm the Industrial Applications Manager for Trotec Laser. And today we're going to go ahead and go through a webinar-based seminar that is going to discuss fabric and the different types of fabrics and capabilities with your laser systems. I'm going to go ahead and move forward here to the screen. Okay, so we are going to be doing an application seminar on processing textiles. Textiles are a very diverse application segment with lasers because there's so many different types of materials out there. And what this means is that you can work with these type of materials for all different types of applications. This webinar will be posted on YouTube. We will also post it so that you can review it at a later date, including all the questions at the end. If you have any questions during this event, you can go ahead and post them on the sidebar right there in the actual presentation. And at the end, we're going to go through the questions one by one. Because this webinar is recorded, if you don't have time to go back or wait for your question to be answered, you can come back at any time on the YouTube channel, take a look at it, and see that answer at a later date. This, again, will be posted on YouTube. You can scan these QR codes if you want to find out where that is. Scan the QR code to subscribe to our YouTube channel, Facebook, Twitter. Any of our social media platforms tend to post this type of information. Moving forward here, a little bit of outline of what we're going to do today. We're going to do an overview of textiles, what they are, advantages from the laser systems, processing techniques for the laser system, advanced application, accessories required to process those materials, as well as inspiration. And then we're going to cover some Q&A, answer any of your questions that you may have throughout this. Don't forget, if you do want to go ahead and post your questions, you can do it when you have that question during the event. So don't think you have to wait until the end just because that's when I'm going to answer the questions. So go ahead and post it when you have that question so that I will do them in line as we get time to do that towards the end. So moving forward here, laser compatibility. With fabric and apparel type applications like that, the CO2 lasers are the primary application. There's a lot of lasers out there, most of which are CO2. And CO2 is the right wavelength and type of laser for processing fabrics because it works the best with the materials. Other lasers like fiber lasers really won't do anything with this material. So CO2 lasers are the most efficient ways to cut and engrave any type of textile. Trotec at least makes the Speedy and the SP series are the most popular models for that. Speedy series is 12 by 24 up to 40 by 24. It is the fastest laser engraver on the market with up to 170 inches per second. JobControl software, intuitive software allows you to work efficiency with it. If you want to go larger than that, we have our SP series, which is a wide format, and it'll actually go out to up to 128 by 126 inches. So large formats, bolts of fabric can be processed with it, as well as the smaller machines, both of which use JobControl. Textiles suitable for processing, there are all types. Really, all fabrics can cut with a laser. Some work better than others. You're going to find that they all pretty much cut, but engraving can be a difficult one. Some of the more common are going to be your Alcantara, which is your micro-suede material, cotton, felt, fleece, jeans, lace, linen, polyester, silk, soft shell. This is just a few examples. As I said before, pretty much any type of fabric will cut. Not all will engrave, and I'm going to go into some details on that, showcasing how we're able to engrave some of them, and some of them produce a much better effect when it comes to engraving. Others are just going to be able to cut with the materials. Now, the lasers allow for cutting and engraving of a variety of textiles, and so it really doesn't matter. Like I said before, some work better than others, but in the industries that this works when, it really doesn't matter. Clothing, automotive industries, curtains, drapes, decorations, design, promotional items. It does not matter if it's in a binder or if it's on a dress. Ultimately, the laser is going to do something for that. Usually, like large patterns and cuttings and like that, you're limited to field size, and so most laser systems being smaller are not going to allow for that. So it's more your designing, your decorations, promotional items, things like accessories for like hats and stuff like that, patches, so on stuff, things that can actually fit into the machine. But most industries utilize lasers for apparel decoration and cutting, and it is a big benefit, and I'm going to go through a lot of these benefits for that. So here are the advantages of laser technologies and why laser is kind of has an unfair advantage over other operations for processing a lot of these materials. It is a non-contact process, and this is a huge benefit versus, say, cutting with a traditional knife cutting. So there's no resistance on the material. Laser machining is a contact machining, so it doesn't process the material, so it's not going to warp it. Your knives are not going to constantly dull, which they tend to do. Scissors tend to dull. You get fraying, you get other problems on the fabric. Lasers give you that nice, clean, consistent cut when processing materials without the need of actually touching or contacting the material itself. So it makes it very easy to process these types of materials. The other advantage is the edges when cutting the materials are perfectly sealed, especially on your polymer-based fabrics. Polymers, which is a plastic base like your nylons and your polyester-based fabrics and stuff like that, will actually seal the edges, keeping them from fraying. So that is a clear advantage over mechanical means, due to the fact that the laser's heat will actually keep those fabrics from fraying afterwards. Natural fibers like your cottons and wools and silks and stuff like that can be, it won't actually seal the edges, but again, it will give you that clean, consistent edge. You're not going to get any tears or rips or mechanical problems when they tend to dull, because that laser is always perfectly sharp. So that is a clear advantage of the laser system. The intelligent routing of the airflow and high quality access drives gives you also consistent precision and accuracy, so that you can cut consistent results constantly over and over again, repeatability without ever needing to basically replace, sharpen, or have a failure rate when processing these materials. Contour cutting is very accurate. Cutting of the basically cutting of printed materials are precise, such as banners and flags, so that you can get that nice outline contouring effect with it. JobControl will actually create compensate for distortions in printed designs and automatically adjust, so there's absolutely no positioning required using our camera registration. When laser cutting textiles, the material fuses, resulting in a clean, perfectly sealed edge, as we said before. So this is just, again, we're going through kind of that advantages using the capabilities, and we're going to get a little bit more into like the job control, camera registration, when and how to use those type of applications as we get further through this seminar. High quality manufacturing, designs are creating in typical graphic software. If you've never done fabric or any type of apparel cutting with the laser, you design it in your design software, and then you send it to the laser just using the print command. And then you're able to get that high quality printing or precise tactile effects that cannot be achieved through other type of printing process. So this is more of your engraving into your fabrics. So most printing onto fabrics is done with inkjet printers and stuff like that, where lasers are engraved into the surface of the material, giving you that tactile effect. So when you do like felt and flock and fleece and microsuede, you can actually feel a little of the engraving depth into some types of fabrics. This does give a clear advantage. It produces a high perceived value on a lot of fabrics, and then also because the lasers are so consistent, the designs can easily be reproduced, always with the same quality and appearance. And so it is a repeatable manufacture process when you're engraving it. And I'll show you some examples as we move forward here. One tool basically for all shapes. The lasers, and again, an advantage, the diameter of the tool does not have to be taken into account. A lot of times mechanical engravers require compensation for kerf. Because the laser beam is so small, we can get in with that laser beam and cut out little intricate details, because the beam diameter is 3 to 4 thousandths of an inch, or 0.0039, depending on which lens is used. And because of this, you can get those kiss cutting, those cutting abilities without having mechanical shears. And so the detail that is possible when cutting fabric, especially as well as engraving, but when cutting a fabric can dramatically be improved over traditional mechanical means. So the beam on a Trotec laser provides an ideal optics and optimal performance into those intricate details. So these are just the advantages of the laser systems. And again, no wear. You know, mechanical tools tend to wear. Mills, cutters, scissors, everything like that is going to wear out over time. They're going to dull. Lasers don't dull. So the beam is unaffected by the wearing of the material and the processing of the material. With the Trotec ceramic core, you're going to get years of unparalleled long-lasting life and service on your laser system. Now, processing with the laser system, we're going to go through some of the different techniques and show you the details of what it is, how it'll work, and why you would potentially want to use this capability on specific applications, materials, and maybe in certain markets. So textile processing can be done onto lasers. The one caveat is you want to make sure the material is as flat as possible. Trotec has a lot of different abilities to do that, such as a vacuum table, magnetic table, the ability to tape it down, use magnets to hold it down, templates, masking tape, whatever is necessary. Some people will actually use a large piece of acrylic, cut a little bit smaller than, say, the piece of apparel they're going to do, and they place it over it and then have a large hole in the center. Kind of produces a hoop effect to keep that fabric very, very flat and straight. When engraving and or cutting with the laser system, it needs to be kept perfectly flat. If you get a ripple or a wrinkle into the fabric, I don't care if you're engraving or you're cutting, you will see the effect into that finished product. So you want to make sure to use as much process or laser hacks or techniques to keep that material as flat as possible. Air assist should be on when using this process. Use your downdraft vacuum table if you have it, or a downdraft cutting grid. Block off any excess material to keep it flat. Like I said, using the magnetic table, especially if you're just engraving it. Cardboard, masking tape, anything you need to do to keep that material flat when processing it with a laser system. Now, for running a material, especially if you don't understand the material settings, because there are so many different types of fabrics and different types of materials and blends out there. So it could be 20% polyester, 80% cotton. You never really know what the power setting may be. And so preset or material database settings are rare in this category. Because of that, it comes down to you to kind of dial in the power settings to make sure they're processed right. And so typically with fabric, whether you're engraving, usually when you're engraving, you want to start at high speed and low power and then just up. You bring it up. Rather than start high power and go low, you always want to kind of creep up on that material. So lower your correction of jump to compensate for the unevenness that the material might have. You basically want to adjust your speed and your power appropriately, starting low and then moving high, especially on your power. Advanced options under materials database will allow you to control different corrections. When you're engraving at resolutions, typically 250 and 333 to 500 dpi is the best for engraving graphic. I like the lower resolutions personally because fabric is a material that doesn't really require a lot of resolution and detail. So 250 to 333, you can go as high as 500, but no higher in most cases because fabric is so forgiving, kind of like something like wood, but it also doesn't require much power. Low resolutions not only improve your processing speed, but it produces a much cleaner finished result, reducing the chance of flaming. You get a cleaner finished result when you're finished. So when you're processing fabric, especially on engraving, try running at a lower resolution, 250 to 333 typically. Now cutting your textiles to size can be done efficiency and ease with the laser, but the one drawback with a laser system is you can only cut one single layer of fabric at a time, with exception of twill. And the reason this is because when you try to cut stacks of fabric, and that's where some of the mechanical means that can cut 40, 50, 100 layers at once have a clear advantage when they're doing like large clothing. So laser systems, when you try to cut multiple layers together, you tend to either get residue that forms between the layers, or the heat builds up between the layers and can cause damage, or materials like polyesters and your synthetics can actually fuse together. And when they fuse together, when you go to pull the parts apart, they're literally one part. So that becomes a problem. And this is why you need to kind of run one layer at a time, with exception of like materials like Twill, which we'll get into in a little bit later. Complete cuts with efficiency and acceleration compared to knife processing. And the other advantage is, a lot of manufacturers will use knife cutting for the large areas, and then the intricate small detail they'll put in one at a time, and they'll use the laser to finish that up because the knives can't do it, and then the lasers can. So they can work very well together. Again, fabrics are untouched, eliminating any type of warping, and the laser beam can melt the material, providing a sealed edge on some of the fabrics. Now, engraving into the textiles can produce a tactile or a neat, really kind of a neat effect, and can't be really produced any other way. Direct textile engraving basically can compromise the integrity of the material, so you want to be careful. Too much power setting can produce a beautiful effect into fabric. However, that problem, when you go to pull on the fabric or wash that fabric a few times, it starts coming apart. So there is a very fine line in engraving fabric, how much depth you can engrave into it, what kind of contrast you can get, the color of the fabric, the type of the fabric. So there are not as many fabrics that can be engraved. And I would say maybe 5 to 10% of the fabrics out there can be engraved, where all of them can be cut. So we just you have to understand which ones are going to work best for engraving versus being able to cut. And we're going to cover some of the more common ones that can be engraved. Most fabrics, just so you know, like I say, 80 to 90% of them cannot be engraved. You can engrave it, but then when you go to stretch that fabric, it will start tearing it. The contrast will be low, and it just does not look good. So we're going to stick with the ones that we know work really well. If we're not sure, we can always run tests. You can always run a test, but I suggest you run a test on a material if you're not sure. Run a test, pull it, stretch it, make sure it doesn't crack or break. Run it through a few wash cycles if necessary before you do any type of production. Fleece and microfiber typically produce a darker contrast result and are one of those materials that are very engravable. You see a lot of fleece jackets with a logo engraved into it because fleece has what's called a pile. A pile is that fuzzy surface, and then it's got a backing on it. And that backing is kind of a woven back plate, or not a plate, but kind of a hard weave. And then the fluffy surface is what you kind of melt to produce the contrast with the laser. So fleece is a great material for engraving into the surface of the material, produces great contrast. Most colors work. I've done everything from black to white to red to green. They all produce contrast. It looks really good. Tight cotton and denim also produce high contrast and a bleached appearance depending on the color. So you got to be careful on denim sometimes. Like black denim can sometimes absorb too much of the laser beam and it won't work as well. Where like the blue jeans and blue denim work exceptionally well, which we'll show you some examples later. And so it can not only be the type of material, but can also be the dye that the fabric has been placed onto it in some fabric. So like cotton, like I say on a denim, if you have a black denim, sometimes it doesn't work where the blue does, just because of how the wavelength of laser light is absorbed into the material and how much heat it's absorbed to it. We'll get into some techniques on how to reduce that by like wetting your fabric down going into it in a little bit. But there are ways to kind of reduce any chance of fracturing or damage to the material, at least somewhat. When engraving lighter textiles to achieve darker contrast, you can try defocusing it, basically making the beam a little bit wider. And in some cases, that adjustment of the Z offset, making it a larger beam, will actually produce a darker effect, and it won't engrave as deep into the fabric. Maybe you just want to bleach it and you don't want to do that. You're not going to get as much detail when you do this. However, you will potentially see more contrast. And if it's just big, bold block letters and stuff like that, you can play around with this technique. I do recommend defocusing by going away from the material, not towards the material, just for the sake of if you ever have a flare up, you don't want your lens closer to the material. You always want it further away. But both will produce the same effects. Just for safety, I always recommend when defocusing, go away from the material versus towards the material. Cotton is one of the most widely produced natural fibers on the planet, accounting for 90% of all natural fibers in the textile industry. It's durable, comfortable, variety of colors, versatile, can be woven into many different other fabrics like denim and fleece. Cotton is great for want to lose a flit, and it dries slowly, and it's not really ideal for active wear. But different colors in contrast are workable with the laser, and we're going to get into it a little bit here. Laser processing cotton can work really well. We recommend using low power when processing cotton, about 20% of 100 watts. So if you got an 80 watts, you're going to be about 15%, as well as moving the Z offset. I do also recommend when processing cotton, besides adjusting your Z axis, something that I've always used in the past is slightly wetting down that fabric. Wetting it down is going to reduce the chance of any of those fibers being broken from the lasering process. When the heat hits it, all we want to do is produce a bleaching effect. And that bleaching effect, like you see here on the little robot on this shirt, is the process to where the laser's energy is just enough energy to take that dye or the color contrast away from the fabric, basically bringing it back to its original white state, or there as much as you can get. And so playing around with the power settings, if you want a little more contrast, you wet it down. Understand when you wet it down, when it engraves, it's not going to be as white that you think on the power setting. You'll have to engrave it, and then you're going to have to let it dry to truly see the finished effect. So when you're doing testing, make sure you once you've wet it down and you've engraved it, just because the contrast isn't good, you want to wait until that fabric has dried out. Stick it on a heat press to dry it real quick, throw it in a dryer, stick an iron on it, whatever's necessary to truly bring out that contrast and make sure your setting is right. Then you would want to, of course, stretch it, make sure that it's going to not, the fibers aren't going to break. You'll know really quick if you've hit it too hard, because your fabric will be torn and fibers will break apart when you go to start moving it around, or if you take it through its initial wash. Polyester is another great material, but it is a man-made material. And this is unlike cotton material, which is a natural fiber, the man-made polyester is great for your, materials that is waterproof and stuff like that, because it is made from a polymer. Polyester is a man-made fiber derived from water, air, coal, and petroleum. Basically, it's lightweight and soft, more durable than cotton, stand up to a lot of wearing and washing, quick drying material, makes it great for active wear. That's why you tend to see this, or you see this mixed with cotton. So you kind of have the best of both worlds in some cases. Polyester reacts really well to laser processing. Applications with synthetic substances can be laser engraved. However, you got to be really careful when laser engraving polyester, because it is a polymer. It's a plastic. And so if you hit it with too much laser power, when you go to stretch it, those plastics, that engraved area is going to crack and it's going to break, and things are going to not work as well. Laser machines are ideal for laser cutting polyester because the edges are sealed. And this is where you get that nice sealed edges. The plastic literally seals together and gives you that nice edge quality that cannot be processed in any other way. Now, engraving it can be tricky, and there are some types of polyesters like your micro-suede that work really well because you're melting the surface of it, but the backing or the batting of the fabric keep that from breaking apart. And so it can be engraved, but it doesn't necessarily work as well on some of your solid materials, unlike materials like microsuede, which is polyester. So this is kind of like the fleece, and the fact that it's got a pile on the surface, and basically that fuzzy surface. And from that fuzzy surface, as you can see here from the Trotec logo on 3 different colors, it works exceptionally well for contrast. And because the backing is a different type of fabric, and it is than the surface, you do get that contrast. And so this is a rare example of a polyester that works very well with the laser on engraving. You'll see this stuff make It's everything on your couch to your car seats. It's used everywhere. You see made out of pillows, but it's soft, it's long-lasting, resilient. It looks like a suede. It's a polyester leather substitute basically, and it engraves beautifully and works with just about any color. I've even done black and it produces contrast. White wasn't as great, but more of your midtones work the best, like your tans and reds and greens and blues and stuff like that tend to produce the best contrast, I find. But it reacts very well, and you can see I can get some really good detail on it as well. I'm able to put barcodes on it. This sample you see here is only 10 inches by 10 inches. Full photograph, QR codes, barcodes, text, font size down to 2-point that is legible. So it is a very engravable material. Unlike, you know, just like the polyester flat material, which I would not be able to do this on, the microsuede will give you that ability to do that real good detail. So if you want a material that produces probably the best contrast, one of the easiest materials to engrave with your laser, go with the microsuede type materials. Here's some examples. If you want to scan these QR codes, it'll be taken to an actual DIY, so you can do it yourself. Files and instructions on exactly how to do it. Just turn your camera on your phone and point your camera at these QR codes at the bottom of the screen here. It'll take you to the location and show you an instructions on exactly how to process these materials, as well as give you the files to do it yourself. So if you want to do something like this and you want to process something like this, just kind of practice, make a pillow. Of course, you can modify what it says on the surface and then make something yourself. These are great tools for you to go in and practice with this process and kind of see the files and the settings and stuff that are used to do that. All pertinent data to make these are in the file. Just again, point your camera to the QR codes down below here and go ahead and go to that should you like. Again, this seminar will be recorded later, so if you recorded for later, so if you want to come back to this, point your camera at it later to run it, you're welcome to do so. Denim, we kind of covered cotton earlier, but denim is kind of its own category. Denim is, because of the way that it's done, it's a cotton blend, twill, textile woven, and color warped. It's firm and durable. One of the most popular apparels today, blue jean jackets, shorts, skirts, overalls, everything is made out of it. And it is kind of become its own offshoot of cotton, and because it works so well with the laser system, we're breaking it apart here and kind of showing that it can be processed by itself because it's so popular. Denim is a great material because it is uniquely suited for laser engraving application. Dark washes of denim can actually result in high contrast engraving, producing a bleached effect. Black and white denims won't process as well, so you want to be careful. I found that it depends on the manufacturer, what kind of effect that they actually use onto it, what kind of dyes they use. So don't assume that all denim is created equal, because there are so many manufacturers out there that produce this type of material. Everyone seems to work a little different. And with my testing that I've done on this in the past, I have found that most work pretty well, but I have run across stuff that will produce problems. However, I would say about 85% of it is really good. Most of the blue stuff is the best, and it produces great contrast, fine detail. I do recommend that you do wet it down a little bit when you process it to reduce the chance of any overpowering or burning of the fabric. It's a great trick to keep it. Again, the engraving won't come out as light until it's dried. So make sure you've dried it out to make sure your setting is right. Don't just assume you've hit it with too much or not enough power when you processed it. Usually when I'm testing denim, what I will do is, if I've not done a brand or a type before, I will take and engrave, I will wet it down and I will engrave 10 or 15 different settings onto that piece of material in just a black box. In those different settings, you can use the power profiles, or you can use color mapping. So you can just take all your colors in your color palette and change them to a little bit different setting, 2 or 3 different percentage of difference at the same speed, and then engrave them all. And then you go ahead and dry your denim out, and then you see which one produced the best contrast and didn't tear. And then that's going to give you your ideal setting for then your production, as long as you stick with the same brand of denim at that point. It does requires no post-processing. It's a lot to save you a lot of time and money. It's a great material to work with. And as long as, again, you got to keep it just like any other fabric. You want to keep it as flat as possible when you're processing it. And so, as I was saying, dampen the denim for processing. Defocusing can help as well. Again, we're trying to produce a bleaching effect that is going to produce contrast without damaging the fabric. And this is where defocusing, wetting it down, dampening it will produce better effects. And so a little bit of trial and error on the fabric or the denim that you're processing with is necessary to get the best result. Don't just assume that there's a preset. It is a little more of an advanced type application. So practice before you process any type of customer or product or process or something that you're going to sell possibly. Or if it's a one-shot deal for a customer, I would hesitate if you've never done this material before. But defocusing it, playing with a little bit of the dampening. And when it comes to dampening, you don't want to get it like wringing wet. You can take a spritz bottle over the top. You just want it damp. You don't want it to where it's dripping wet. You don't want it to be like super wet, but you also don't want it to be like dry. So it's kind of a fine line, kind of like when you take something and wring it out. It's damp all the way through, but it's not drenched. So that's kind of the threshold I do. You got to be careful too. If you're doing too large of an area, it can start to dry out as you're engraving an area. So sometimes you may have to actually pause a machine, re-wetten it, or run different sections and then re-wetten in between if your exhaust tends to dry it out in some cases. So again, it is a process of love. You really have to know this process and play around with it to get the best effects. Here's a little video here that's going to show you the process that of engraving some denim jeans here. If it'll play. Okay. Technical difficulties. Huh. Well, anyway, I was going to show you a video, but apparently the video decides it does not want to play. Oh, there it goes. Well, at least the audio. Not look like it. It looks like it is technical difficulties. So we will post this, and so then double check the video. I'm not sure the videos are going to work for this. I'm not, and I'm not sure why. So we're going to move on. But basically, we will also post this on our YouTube channel if necessary. But we'll figure this out. But in essence, it's just showing the process of engraving denim and kind of showing that process. So I apologize for that. We'll have to figure that out. Moving on here, silk. Silk is a great material as well because it is a natural fiber produced by insects, made primarily of a microfibrin known as a soft, shiny texture, durability, elastic, absorbency type fabric itself. It can be cut beautifully because, again, it is a natural fiber. And that fiber can be also engraved very similar to the denim. You can get that contrast into it. You can kind of wet it down again, just like you can with the denim, and bleach off that excess material, producing that whitish effect. It is a little more sensitive, and it does require a little more trial and error, but it is a nice material. Works a lot like the denim in the contrast. Cutting, of course, will be no problem, producing that nice, clean cut, sealed edges with the laser system. Fleece is another great material that works with the laser system, kind of like microfiber, but it's got a larger pile, so it's a lot fluffier, or it sticks out a little bit more. Fleece is a synthetic insulating fabric made from different types of polyesters and synthetic fibers. Lightweight and comfortable, anti-perspiration qualities, moisture, evaporation, humidity outside, because it is made of a polymer material. It is a great material for engraving, because just like microsuede, you're actually engraving away that pile or the fluffy surface down to the base. And so you do get that contrast into the surface of the material. Tends to always engrave a little darker. So the color you're going to get, it's going to engrave darker into that. I've even done black fleece, and it produces a blacker black, and it's really classy looking. So I've done white fleece, I've done black, I've done reds, greens, yellows. Pretty much all colors are going to work with this material. You can, some different techniques onto it. You can convert your image to a grayscale, and it separates the dots out a little bit, kind of gives you a halftone effect, and will produce less removal in the material, so that you don't get as much melting effect. Again, just like we did with the other fabrics, we can offset our Z just a few millimeters, and we can run resolutions. I find, again, around 333 works really well, up to 500. Cutting frequency at 1,000 to 3,000 hertz, going to give you that nice sealed cut edge. But this material works very well with the laser system. It doesn't require a lot of laser power, depending on the pile. And the pile is basically how thick the material is and how fluffy it is. So the thicker that it is, more power you're going to need, a little bit slower possibly. I always start my fabric at 100% speed when engraving, and then I start my laser power pretty low, and then I'll bump it up. And you can actually adjust your laser setting on the fly if you want to see it happen, or you can make little adjustments, pause it, make adjustment, resume it until you kind of dial in that setting. And then I suggest, if you're deciding to do something like any of these fabrics, then make a setting. So create a setting in your database for fleece, and then that way you have one from then on. Felt's another very popular material. It is basically made by wool or fur being processed into natural or synthetic fibers, processed through heat, moisture, chemicals, and pressure. Felt or felted wool. It's inexpensive, versatile material. Available in a wide range of colors, very common for crafting type applications. Again, it is probably most commonly cut with the laser, but can also be engraved. It is typically the synthetic ones are the more common. And one we typically process are the 100% polyester felt, suited processes for the laser. I have found and tested just about every felt, and they all cut. Some don't engrave with a great contrast, but they all cut beautifully. The polyester felt is extremely durable because it is kind of that polymer type effect again. So the edges are sealed. It's durable when laser cut. Again, same process a lot of the other fabrics, engraved with an offset with the Z, resolution as high as 500 or lower depending on the contrast. Cutting frequency, just like any other polyester, 1,000 to 3,000 hertz. And then you're able to get that effect. It's a very easy material, comes in a nice flat sheets. It's easy to keep flat on your laser system or your cutting grid. And so it's going to give you the ability to work with it. A lot of different crafters love this material to work with it because it can produce, it produces in so many different colors, and you can do a lot of neat effects into the material itself. So great material to process with it. Here's another QR code if you want to. You can scan this QR code, and you can go to this little project right here, and it will take you to this project, and you can actually process it using the felt, should you like. So we're going to go into some more advanced techniques right now. We kind of went through some of the more popular fabrics. And if we didn't touch into your fabric, maybe the one you're interested in, it's probably because it's not the best suited for the laser. That doesn't mean, again, it won't cut, but for engraving and stuff like that, it's probably not best suited. Advanced techniques are going to be materials like leather. And leather is one of those materials that is, it's a tough material. It's not really a fabric, if you will, because it is made from a hide, but it is a material that is in the same kind of market segment. And so we're going to include that. And so Leather is a tough, offers strong resistance to every tool used aside from the laser beam. And so the lasers give a clear advantage when processing leather. Leather is one of those materials that is hard to cut with mechanical means. It can be processed. It's very, very, it requires a lot of processing techniques and stuff like that to do that. And so lasers give you a real advantage in the fact that the lasers can both process genuine and synthetic leather, like leatherite. But the thing is, you got to be careful with leather on your laser system. Is there may be types of leather out there that is the synthetic leathers that can contain PVC. So it is not the synthetic leather. You want to make sure that it does not contain PVC or polyvinyl chloride. And so be careful. Make sure you check your manufacturers if that's the case. And then also natural leather. There is one type of natural leather out there that is rare cases if it's been chromed with or finished with Chromium IV. Chromium IV is very dangerous when burned and can be dangerous to your health. And so you want to stay away from leathers containing Chromium IV. I would say about 98% of leathers that you buy, natural leathers, do not contain this. So you just want to be sure if you're buying something from overseas, it seems too good to be true on prices, just make sure that it's not tanned with Chromium IV. And so because of the dangers of it. So you want to stay away from those two materials. Now, all other synthetics, as well as most of your standard leathers, are going to be just fine. But I do want to work with that just to let you know those capabilities. Processing leather is pretty easy with the lasers. Cutting it, the lasers melting the material, especially your synthetic leathers. And your synthetic leathers produce a clean, sealed edges. Engraving it creates a tactile effect. It makes it easy to customize or produce a beautiful finished product. Contrast is always going to be darker. So when you engrave into the surface of the leather, I don't care if it's white leather or black, or if it's your tan colors, reds, it's always going to engrave darker into the leather, unless it's a synthetic that is designed to do otherwise, like your leatherite, which actually has a layer inside, but it's synthetic. So you want to be kind of understand, in most cases, unless it's designed otherwise, it is designed to engrave, or most leathers will engrave darker. Leather types that are suitable for laser engraving is going to be your natural leather, suede, nap leather, nubuck leather, synthetic leathers, Alcantara leathers. These are just some of the more common. Vegetable tanned is probably my favorite, which is your most common out there. And it will again produce that darkened contrast into the surface of the material itself. Genuine leather is a natural material, but there are countless types that respond and they respond individually to laser processing, making it difficult to determine the rules for processing. I know Trotec has a preset for leather, but that leather is, again, it's very generic in its term. If genuine leather is distorted, reduce the laser power. If you get a lot of angling or distortions, you kind of want to play around with your power settings. If you engrave too deep into leather, it can be a problem. Too deep, you want to engrave just enough into leather to where you produce contrast, but not too deep to where you start to see distortions, kind of like you see in this photo down below, where it's kind of bowing up from the heat of the leather. Especially some of the synthetics will do this. So different applications. I mean, everyone has pretty much seen leather is probably one of the more common materials, but you know, in our marketplaces, we tend to see it more of your belts, bracelets, shoes, purses, wallets, briefcase, clothing, accessories, office, promotional, crafts. That is kind of our market segment for lasers. So different types of applications when you're doing like large cutting areas and stuff. If you can't fit it into the laser system, then it can be difficult to do that. Smaller components before they're stitched together can, of course, be cut out. I know a lot of cowboy boot manufacturers, a lot of leather companies that make like saddles for horses and stuff like that use the lasers to cut out all the intricate little details. But you want to, of course, make sure that it's going to fit into the machine. The other thing is when you cut leather, the edges can be will be dark. So mechanical means will actually produce a cut into the leather that is going to be just the color of the leather. So when you cut with a laser, you are going to have a dark edge. And here's a great application that has become very popular for the laser system, and that is patches. Patches on hats, on pockets, and they're basically stitched on, they're heat pressed on. Here's a QR code you can scan if you want this project file, and you can do it yourself. I've seen a lot of companies going to where they're printing on the surface of leather, and then they're using the camera registration to then cut out the patches. So you can do an actual leather patch that's been print and cut on leather, and then it's stitched or heat pressed on. This has become a huge application market segment, and it's growing exponentially over the last few years. And I do suggest, if you have the marketplace for it, so if you want something kind of new to play with, then I would suggest maybe playing with this. And if you scan this QR code here, you can move forward and download some of these files and see the project and make some yourself. Here's another one on engraving a belt. Belts are a great one because, you know, it's fashion scent. It fits very nicely into the laser system. You can cut the outside shapes of the belts out. You can, of course, engrave the detail pockets. You can cut all the holes and stuff into the belt. All the individual components can be cut out from a piece of leather to actually create belts. And here's a QR code that will take you to, again, another file, DIY of the process, and it will give you that kind of a project effect if you want to work with it. So that is leather. So any questions on leather, let us know. I know there's a lot of them out there. Leatherite is a new popular one from JDS, which works really well with the laser. It's not really leather, it's leatherite, which has all the contrast, and it does produce different contrasts into the material other than a dark effect. So that's another great one out there, and has become very popular. Besides leather, layered fabrics, another very popular one, has been out there for the ages of laser systems, and that is twill. Twill is one of those materials that, again, it's polyester, cuts beautifully with the laser system. Lasers can cut and seal the edges. You can see here the lasers can cut different numbers and letters. They can be heat pressed on, they can be stitched on. Here's a great example of where the laser actually produced the sewing machine stitch onto the surface, and then it's heat pressed on. So it looks like it's stitched, but the laser marked on the surface to produce the contrast, producing a look of stitching, but not actually having to put it on a sewing machine. And then this is heat pressed onto the surface of the material. Lasers cut out 1, 2, 3 layers at a time. This is one of those materials you can do stacking effects onto it, and then you can peel up what you want or weed it. So the laser will go through 1 layer and then to 2 layers. You can do, I've done as much as 3, even 4 layers, but it becomes more difficult because you're weeding out the different layers, and then you're dialing in the settings, the power settings, to get through each layer separately. And now it does require a weeding, which means removing the areas that you want that contrast to be shown. So this is a great application for doing this type of for doing it. There is really no better way to do twill than on a laser. It's fast, it's consistent. You can produce the stitching effect. It is heat transferable. It can then be, of course, that digital design file that is created from the laser can then be sent over to most of your embroidery machines, and then it can be embroidered on. It can then be stitched on. It can use reference points to actually create a stitch pattern so that it can be stitched onto it. And utilizing different types of technologies, sewing technologies, softwares, it kind of works really well. Again, no mechanical wear. It produces a flame polished edge. And it is just one of those great materials that I would suggest, if you're not working into sports, twill is a great material to work with. So here is another video. I'm going to try this again and see if the video will work this time. I have a backup this time, I think. Let's see. work this time. Excellent. Okay. Couple other ones here is the heat transfer material. Heat transfer material is a great material. Some of the two companies that I have worked with in the past is Caesar and Stahls. They produce the CAD cut heat transfer vinyl material. They call it vinyl, but it is not made of vinyl. It used to be made of vinyl. In a lot of the industry still call it vinyl. And so that can cause a red flag for a lot of people. But most of these, and you want to make sure of them using companies like Stahls and Caesar, because they produce they produce contrast, or they produce this material that is not made of PVC. So vinyl must be laser safe. This is a great material because it can be both laser engraved and it can be laser cut. And when you process this material, you can then cut it against a thin film, and it will actually can be weeded up, or the laser can etch it away from that film to produce the contrast, and then it can be heat transferred onto apparel. This is a great material because unlike Twill, it is a much thinner material. So it's pliable. It looks like it's almost been silk screened or printed onto the surface of the t-shirt. And the lasers can give you that nice, quick, easy cutout. It can be weeded up or it can be engraved away. Large text, like you see on this shirt here, will produce, is much easier to cut out with the laser. You do what we call a kiss cut, where the laser cuts through the surface layer of the material, and then it is weeded up. The excess material is weeded away, which is a much faster means of doing it. There's also a process to where you can put it on like a tacky mat, keeping it flat, which I will show you here in a few minutes, and it will engrave it away. So this is a great application for it. Here is another video that will showcase that ability. This is the heat transfer film that is able to engrave it here. So I'm gonna show you the ability to do that. This is used with a, make sure it's playing here. Give it a sec. Intricate engravings and stuff like that. It is still best suited for cutting with the laser and then weeding out the large area. It's not possible to really, it's not real probable to engrave away everything. It would take too much time. But small little engraving area, it is recommended to do the engraving process with that, because as you can see there, you can be heat transferred onto the surface of material. So if you're doing small text areas, detailed areas, labeling, where you want to be able to get that intricate detail, but you don't want to sit there and pick out all the excess material, you can use the laser system to do that. As you saw on the video, the recommended solution for that is to use a tacky mat. A tacky mat is a sticky mat which you can pick up through like JDS, and this holds the material down and keeps it from pulling up. Even a vacuum table won't work, and so you want to make sure you use a tacky mat if you're going to do that application. And then it can still be a little tricky, so you want to play around with it. Contact us if you do want to do it, but usually it's done with smaller areas for that, and then larger areas are cut. So we're going to go through now some accessories. Accessories are different capabilities of the laser systems to enhance the apparel type applications. Accessories are going to allow your textiles to lay flat when processing. There are things that we're going to want to do to make that work. Laying flat, compensate for unevenness by utilizing longer focal lenses or moving the laser out of focus. We have multifunctional table options. We have a ferromagnetic table. The ferromagnetic table allows you to actually fasten and hold your material. So if you're just engraving, say, a jacket, maybe you want to stick a box or something onto the table, and then you want to have it drape over the edge, and then you want to use magnets to kind of hold it tight, flat over the type of box or a hoop or something like that. The ferromagnetic works really well. If the fabric kind of lays flat, you can use magnets to kind of stretch it out, which is nice for that. Vacuum table also does the same thing. These are great if you're just engraving, but if you're cutting through the material, you want to use the vector grids or the cutting tables, and then cover up any excess of that material to create as much vacuum as possible to hold it down. And you can get creative. Use weights on the edges. You can use pieces of acrylic that physically go around the outside of it. But we offer a lot of different types of tables depending on the type of fabric that you're running. Aluminum cutting grid table is ideal for your vacuuming type if you have the right machine. Our Speedy 360 and 400. Our slat table, aluminum cutting grid, slat cutting table, vacuum table, ferromagnetic table are probably the most popular for just holding it down, as well as a honeycomb table. So lots of different solutions depending on the type of fabric, application, or material you're working with for and whether or not you have a machine that will support all these will depend on whether you're able to do some of these materials. I do like sometimes the slat tables too, because you can kind of drape the fabric through the slats in the area that you're not, and you can even put weights down below to kind of hold them and stretch them over the slats. And so it allows you to kind of hold it in place as well as cut it. And so it is a great solution as well. So lots of different solutions here on accessories to kind of make the best possible solution for different types of apparel or fabric applications. So here's a little video here of the vacuum table made of acrylic for best engraving. This will increase this effect, block off any, to increase the actual vacuuming, you want to block off any extra of the holes. So the little holes that are in the bottom here basically use the downdraft vacuum to hold the material in place. And when those materials are held in place, they're not going to move. It also, it's really does a good job in keeping all the little wrinkles and stuff down. Again, this is not a cutting table that I would, or a table that I would recommend cutting on. So if you're planning on cutting the material, yes, you can cut on it, but excess energy, if it goes through something like fabric, is going to hit this table, and that energy has nowhere to go after that. And so it's going to reflect right back into the fabric, and it can actually produce some undesirable effects. So if you are producing a cutting effect, or if you do want to cut, I do not recommend the vacuum table. JobControl Vision is an outstanding one. This is something that has become more and more popular in this market segment of apparel and fabric, because as more printing companies have the ability to do printing on the surface of fabric, they have more of a need to be able to cut it out with accuracy. especially on like the patches and stuff like that. So Trotec has the JobControl Vision system, which works on most of our machines. Our Speedy 300 and up all support a JobControl Vision package, and it can be added at any time. And what this allows is it's a USB camera system that allows for a camera to be put into place, and then it optically finds the registration points and then gives you a perfect cutout. It is a great material because the camera actually uses registration software, and then what it does is it actually goes out and finds the registration points, and eliminates the need to actually have to use third-party type software or for cutting pre-printed materials. It allows you to use for cutting pre-printed materials on a variety of materials or substrates. It'll work pretty much any material. So here is a video that will show you this process of how this works. Okay, moving forward here, some inspiration to kind of show you what some of the capabilities are with apparel type applications. There's a lot of different types of stuff that is being done out there. Lasers have given the ability to do things that can't be done any other way, especially in the fashion industry. They're using lasers to cut out little intricate bits and details in apparel that cannot be done mechanically, or it's not effective or efficient enough to do that. And so this is something that you're seeing more and more, especially into the high fashion type application or applications into more high fashion. Yes, it costs more to do that, but they can produce looks that can't be done any other way. Some of the more profitable ones, at least in our market segment, are more of the gift items. You're seeing a lot of shoe manufacturers. I see a lot of boot manufacturers, Western apparel type applications. You're seeing a lot of fabrics wrapped or like leathers and fabric wrapped like booklets and purses and stuff like that. This is becoming more and more popular. And when people want that different look, they want that perception of value or perception of difference. The lasers can provide a look and a feel that can't really be produced any other way. And so it does provide an outlet, especially to these companies that are making these type of products that can't be done any other way. And because of that, it actually produces a higher yield or return on investment. Here's a couple other videos I'm not going to play here, but you can scan these QR codes if you want to see some micro-suede engraving or this doormat engraving, very similar type applications, carpeting or like the floor mats and that you put into like cars and stuff are also very popular. If you scan these QR code, you can watch these videos. It just basically is a simple video showing the process of them engraving. But again, more resources. If you scan our QR code at the beginning of this seminar, showcasing like to our YouTube channel, you can go through all these different ones. I myself make a lot of these different videos that kind of showcase these different abilities. So please subscribe to it. It's content that we provide for free, whether it be content on new material, applications, markets, techniques, service, all the above. They give you a lot of that information so that you have that for the futures. Well, that was it for the seminar. I thank you so much for watching. We're going to go ahead now and pop up the questions, and I'm going to go through them so that you can stay on for this. Again, this seminar will be recorded, so if you want to come back later and hear your question, you're welcome to do so. But now we're going to go ahead and go through the different questions that people may have, and we can move forward with that. So let's go ahead and move it up here. Let's see. Hi there. Have there been previous YouTube live workshops? Well, other companies, the nice thing about Trotec is that all our subsidiaries do these type of things. So if you subscribe to all the different Trotec YouTube channels, a lot of our subsidiaries have done that. We have just started this. And of course, this COVID-19 thing has really helped progress a lot of these type of application type seminars and stuff like that. So we are going to be doing a whole lot more of them as we're coming up. So just stay tuned and keep an eye on our social media for that information. Next question. Do I need to adapt settings or processes from my Rayjet and Job Commander? Rayjets can work the same way. Most of these processes, you may not have some of the accessories like the camera and some of the different tables. Power settings, of course, will need to be processed, but Rayjet is going to work just fine. You may need to dial in your power settings separately, but the process is going to work just fine. Any questions in detail on specific fabrics or type of applications, just let us know, let me know specifically, and I'll help you out. Okay, what do we got? Another question here. Worried about how to do a large piece of jeans, like adult jeans. Any suggestions or images on how to do this would be helpful. A large piece of jeans, like adult jeans, this can be difficult. It depends on how large of the engraving area you're doing, as well as the size of laser system you have. So my suggestion in that case, if you're doing the entire length of the jeans, if you have a large enough laser system, you just want to keep it flat. You want to keep it consistent. Make sure that it doesn't wrinkle, it doesn't change. My suggestion is go to a Goodwill or a swap and get some cheap inexpensive trial pieces to test out first, and make sure you dial in the settings, making sure that it's right before you process any expensive components. How do you get the jeans flat when the rest of the jeans are getting in the way of the laser head? That is a great question. Typically, when I need to keep things flat, I will elevate them. So I will actually kind of raise them over something. I've gone to the point of putting a cinder block into the laser and then draping the piece of fabric over the top of it. So the laser engraves right on that surface where in that flat area, depending on how large of an area you're engraving. You need to get a little bit creative. You can put the area of engraving into a hoop and stretch that fabric out. You can use the magnetic table and kind of use magnets to kind of keep it flat. Wetting it down does help because it kind of keeps the wrinkles from happening. Weights around the edges. You got to get creative when it comes to this. And that is a big problem. Move the table down, drape it over the top of something so that the head doesn't hit any excess material. That's just, it's kind of there's no real quick and easy way or solution that I have found to do that besides that. Next question we got here. Which fabrics do you know are not laserable? I know vinyl or anything vinyl is no to go. And that is correct. Basically, you knew what any manufacturer of materials, whether it's apparel, fabric, or anything else, is going to provide what's called an MSDS sheet, which is the Material Safety Data Sheet. These will tell you whether or not the material has PVC in it. No fabric is damaging to your laser unless it has PVC in it. So you want to stay away from fabrics with PVC. Most clothing is not PVC based. And the reason is because PVC is dangerous. And this is why clothing has kind of gone away from PVC. So in most cases, you're going to find it being okay. You can even look at the label onto the piece of fabric. Most of the time, if it's like a shirt or something, it'll tell you what it's made out of. And in most cases, I've never come across a shirt that has PVC in it. So you're pretty safe. Just be careful. Double check where it comes from. Next question. Is it true the laser beam doesn't like white? Well, it depends on what you're doing, I guess. If you're cutting it, it doesn't care. Yes, white can actually produce a yellowing effect, and it can actually stain the edge a little bit, especially natural fibers. Engraving it, it really doesn't like engraving it because you can't produce contrast depending on the material. So like micro-suede, I get a decent effect in white. But most of your cottons and other material, yes, you're right. The laser beam doesn't really like white because you do get a stained edge. Your engraving doesn't produce any contrast. And so there are cases where certain colors just is not going to work with the laser due to that. How does your laser perform on textured fabrics and substrates? Great question. Textured fabrics are typically, depending on how much textures there's on there. Like your textured fleeces and stuff like that, it usually works very well, but that texture will interfere in what the laser or what the graphic can look like. And so it can be tricky, and depending on what size or type of graphic you're doing. If you're running a larger graphic and you have textured on it, understand that that texture is going to be rippled through your graphic. And sometimes that can be undesirable. And so in that case, it's a case-by-case basis on what it looks like, and testing is typically recommended. What speed on the t-shirt? Speed is a difficult one. You're going to have to email us specifically what machine you run. I typically run all my laser systems at 100% speed when I'm engraving. And then you're going to adjust your power up or down. But if you have a different laser system, your speed may be a little different. But I typically run it full speed when it comes to laser engraving, because it's usually not a power issue. It is or it's not a speed issue, it's a power issue. So I want to run low power at high speed almost on all apparel when engraving it. Now, if you're cutting it, of course, you're going to be at 100% power, and then you're going to bring your speed up as fast as you can get through it with a little bit of trial and error that way. Okay, next. How many washers can you get out of a laser engraved design on a cotton shirt? That is a great question, and it really depends on what power setting you put into it. If you put in more power and you put in too much power, I've seen people only get 1 or 2 out of it and it starts to fray. If it is done properly and you only bleach the contrast away, the engraving should last indefinitely, or as long as the shirt itself. So you should get, you know, what they consider 30 to 50 washes out of it, and it shouldn't fray at all, pending that you get your settings correct. So you got to be careful and run it through a few wash cycles if you're deciding to do this a lot. And once you dial in a setting, you like it, stick with that brand and stick with those settings so that you know if you're giving it to customers, it will last. Does engraving cotton scrubs negatively affect the fabric and the integrity of the fabric? It can. Just as I said before, if you overpower it and it is not done correct, it will affect the stability of those fabrics in some cases. So this is where the wetting down is nice, because it produces a bleaching effect. And bleaching is nice because we're only removing pigment. The water is actually protecting the fibers so that the laser system is only producing pigment, and it does not affect the stability of that fabric, pending you get that right setting. Running slightly out of focus and running a slightly wet fabric can make a difference on that. If you engrave a little depth into the fabric, then yes, it will affect the stability of that fabric. Should you reduce your grayscale percentage on cotton as well? Grayscale percentage is basically adjusting grayscale percentage is going to spread your pulse width out. So it's kind of like producing more or less dots. So the darker you are, the more dots you're going to get. If you are getting some stability issues into your fabric, then I would suggest, as a trick, besides going out of focus and wetting it down, you can also adjust grayscale. That's a great tip as well for doing this. Doing a lighter shade of grayscale, basically the laser is going to spread it apart. You're not going to see as much contrast, but it's going to give you more stability. So yes, in some cases, it is a good tip to play with different shades of grayscale to get a more refined approach onto the material and keep the stability up. So that's a good way to do that. Great question. Next. Is it safe to cut HEPA filters with the laser? I cannot see why it wouldn't. I've never cut a HEPA filter. That is a great question. Just want to make sure that what it's made out of. Typically, I believe they're made out of a polyester or a natural fibers. In that case, it's what they're made out of. It's not one that I've come across before. I can't see why it would be a problem. It wouldn't hurt anything, pending that there's no PVC in there, but I do not believe there is, and so you should be fine. Is there a way to test for PVC prior to using the laser? No, not unless you've got a chemic lab. My suggestion for people is PVC is not going to destroy your laser in one shot. It takes a cumulative running of PVC to actually cause damage to your laser system. My suggestion is to run it at least once on known PVC. PVC produces a very known look and smell. It produces a very dark yellow smoke. It has a clear smell. There's no mistaking it. And when you process it, so go get a piece of known PVC and engrave it, smell it, look at it, burn it into your brain literally, so that when you run a sample or a test, you know that's PVC. I can't run that. Don't worry about it for small runs. It's not going to hurt anything. It takes several months of continuous running day to day to truly cause damage when running PVC. So if you do it by accident, or if you do it as a quick test to make sure of it, it's going to be harmless to your laser system since it's an accumulative problem. Next question. Oh, you're right. Please note that the slide says Chromium 6, not Chromium 4. And it is Chromium 4 that, or Chromium 6 is actually, yeah, that was just a typo, it looks like. And so Chromium 4 is the one you want to stay away from. And so be careful about that. And we'll fix that slide. I apologize about that. Good catch. Next question. Would you need to offset Z-axis to get the black mark on leather? You do good question. If you want a darker mark on leather, going out of focus a little bit will produce a darker mark into leather. That is correct. However, I find if you go too far away, that darkness can start to cause a sooty or a charred effect. And so when you go to wipe over the surface, it can actually stain or skew or peel away, or it just produces a darker effect. So yes, if you want a darker effect, go out of focus, but be careful when you do that, not too much, or don't increase the power too much, because you can cause more soot to build up on the surface of that leather, and it can actually be difficult to remove. So next question. If that's easy to weed, how does it come off in the wash? Typically, the weedable type materials are heat pressed on afterwards, and once they're heat pressed on, they will not come off. They're easy to weed up front because they're not been heat pressed yet. The laser cuts or engraves them away, and then once they're heat pressed down, they are good and known to be good for 50 washes. So no issues at all in that place. Next question. What are the settings for kiss cut on heat transfer vinyl? That is going to be kind of a difficult one because it depends on your laser, your wattage, your type. Contact us specifically and I can give you some guidelines on that. But I would suggest just doing a little bit of trial and error. Just cut a little box and then throttle your power back, running at the same speed, and keep throttling your power back until you get a nice clean kiss cut, and there's your setting. That's how I would dial it in. If you don't want to do that, contact me, contact one of your sales guys, and we can give you at least a starting point and then do a trial and error. But without knowing your wattage and your machine, I can't give you that information. Any tips on engraving heat transfer large graphics? I've followed the no weeding video many times, but I always get distortion and resort to kiss cut and weeding manually. Yes, you will get distortion on large areas, and it's not very effective to engrave large areas anyway because you will start to see distortion. This can be a problem because it takes so much more time. You are absolutely correct. I do suggest kiss cutting and then weeding the large areas and then engraving the small areas. Another thing I will do is I will kiss cut the outline, and then I will cut all the way through, maybe all the center points, so I'm not weeding them out separately, and then I will engrave the intricate details. So in some cases I will do all three. The other thing I suggest is to use a tacky mat. A tacky mat is the sticky mat that's sticky on both sides. You stick the heat transfer vinyl onto it, and it keeps that bubbling or pulling up effect onto it. So you want to use that. It is a troublesome and kind of can be a little bit difficult to process, but there are a lot of different ways to do that. Tacky mat combined with the kiss cutting on the larger areas, do what's the most efficient for you. But yes, you are right, it can be tricky. What HTV did you use in the video, Caesar or Stahls? The one that I used was the heat transfer vinyl. It shows in the video, and it actually tells you it's the Caesar Easy Weed, and the heat. I believe the Stahls was the CAD cut fashion film. Believe it or not, they're both the same material, made by the same manufacturer and purchased by both companies. So Easy Weed and the fashion film is basically the same thing. Next question. My question is, does your machine allow for rolls to be feed? Mylar fabric in general, the software around Mac or PC? Yes, you need to vent the fabric. No Mac, at least on the laser systems we manufacture, and we do not have a roll feeder on our smaller machines. We are developing one of our larger machines, but you're talking, 10 feet by 10 feet. So currently you can work with an integrator. It's a companies and engineering companies that will integrate this type of device into a laser system. Laser systems do have the ability to do automation or output automation commands. What that means is an integrator, which is an engineering company, has the ability to take third-party type roll feeders and then integrate it to the laser to tell it to sequence. And so that's typically how it's done, because there's so many different types of roll feeders, types of materials and fabrics and stuff out there. Most will go to a third-party integrator, integrate a roll feeder into their laser system, and then tap into our automation features to then make it an automated process. We can help you through that process if that's something you're interested in. Is there a test to tell if the leather has Chromium IV? No, there is no. Unfortunately, again, if you're not a chemical lab, you don't want to test it. Usually the manufacturer, again, MSD, actually, any manufacturer that produces a material is required by law to tell them what that material is made out of, how it has been tanned. It is very, very small percentage of the leather is out there that it is produced, uses the Chromium IV process. So you want to just make sure. You need to contact the manufacturer or the manufacturer of the product that you're purchasing to make sure. I have never come across any in the stuff that I have ordered, but I do know it's out there. I tend to find it's the very inexpensive products that are purchased overseas a lot of times tend to have that more so than your just pieces of leather. So just be careful, double check, and do your research to be 100% sure. Can you talk about the impact of different focal lengths for engraving? Different focal lengths for like the lenses. Yes, different lenses and focal lengths from utilizing either by changing the focus from the laser system will make your beam diameter larger, smaller, or you can use the different lenses. Different lenses kind of give you the same effect. So if you don't want to play around with focus, for example, you can go to, say, a 4-inch lens, which gives you a spot size 3 times larger than a 2-inch lens, and that's its focal point. And so you kind of get the effect of a larger beam diameter. You're further away from the material by using different types of lenses themselves. Playing around with different focal lengths can be tricky because the further out, the bigger your beam comes. And you kind of have to keep an eye on how much you go. Every 10 thousandths of an inch, 10 to 20 thousandths of an inch, your beam can increase by about 10–20%. So it happens very quickly. Laser beams are like an hourglass. So the beam comes down from a wide point, and then it then crosses and comes out like an X. So that is your focal point. So if you go in focus or out of focus, your beam becomes wider. So that is something that is suggested that you play around with. The Trotec machines are nice because you can adjust the Z on the fly. So as you're engraving, if you want a little darker, you can adjust your Z button up or down, and then you can actually watch the process happen and actually see it get darker or lighter in those cases, playing with the focus. And then just keep an eye on what that Z axis was. And then you can then put that into your offset of your material setting so it automatically goes to whatever that number is. And we can help you through this process. Next question. Thanks, Dave. Do you suggest doing any samples for individual machine or making settings for each materials? I would definitely suggest doing your own samples and making individual settings if you're doing it a lot. If it's just one-up type stuff, dial in a setting and let it run. If you do, I do suggest making settings for a material that you plan on running a lot of times. It is going to produce a much easier finished process for you, and you're not dialing it in each time. So it's always good to make a setting in your materials database. You can start from a setting like leather if it already works, and then maybe make an offshoot for your leather. Maybe you want a little deeper make. So I tend to always make new settings in my database. It's really easy to do. You just click on it. You can right click and hit new setting, and you can put in your power and speed settings for the new one using the original one as your base, and then make little offshoots, and then just rename it to whatever you want, and then make adjustments as you need it and refine it so that future times you run that material, the setting is preset for you. Have you worked with neoprene? Neoprene works very well with the laser systems. It is a polyester-based foam material, polymer-based foam material. The edges can darken a little bit. You can get a little bit of black when you cut it, but it does wipe off and it does clean. It cuts very, very nice. When you engrave into it, you get kind of that contrast subset. Usually it's black, but it will produce contrast. Works great with the material. So yes, neoprene is a material that can work with the laser. Have you tested cutting and engraving on spandex? Engraving, no. Spandex is going to immediately break the fibers when you go to engrave it. Cutting, yes, no problem with cutting with the material itself, but stay away from engraving spandex. Our fabrication shop just bought a Speedy 400 Flex, which we haven't used yet. Can it perform all the tasks as shown on the demo? Yes, absolutely. Especially if you have a Flex machine, you have the ability to do everything and anything we have shown here and then some. So no problems there. Go for it. If you experimented with different frequencies of lasers, 19 versus 1019, etc., preferred frequencies for specific fabric. Frequencies are primarily used more for cutting. You're not going to see much of an effect for engraving. So playing with different frequencies are not going to really do anything for you. For cutting, it can, because the higher the frequency you go, the more heat you're going to produce. More heat, and you're going to get more of a flame polished edge. You're going to get more of a melt back. So if you do have a fabric that tends to produce too much melt, even though your power setting seems to be right, you can lower your frequency. If you're not getting enough melt or enough kind of a sealed of the edges, increase your frequency. And the higher you go, the more heat you're going to build up, because the laser pulses quicker, producing more heat and give you more of a sealed edge. Mainly for cutting is where frequency is going to be best suited. Would adding food coloring to a spray water for engraving white denim work? That's a good question. I can tell you I haven't tried adding food color to the spray to produce more contrast. I can't see how it would, because food color is designed to kind of wash out. Maybe it would dye it. That's a great question. It's worth a shot, but it's not one I have an answer for you today. Next question. How do I contact you direct for specific project applications? Thank you. My email address is david.stevens@troteclaser.com, and we can post that in the comment section below, or you can just post it in the comments below. You can contact any of your sales guys and they'll get back to you. So it's easy to get in contact with me, because I run the R&D lab here in Phoenix, Arizona. So I've got all the fun and equipment here. So when you do have those questions, feel free to contact me. Next question. What would your concerns be in cutting the polyvinyl defluoride? You got to be careful about that. I believe the polyvinyl defluoride is the safe version of the PV. It's not actually PVC. It's the chloride that actually produces the chlorine gas. So I believe from my research, that is the one safe polyvinyl that is laser friendly. And there are versions out there, and it works just fine with any other type of material. So, but double check that. It's been a while since I looked up that one. And I do know there are ones out there that are safe, as long as it doesn't have the chloride. The chloride produces chlorine gas when heated up or burned. And that chlorine gas condenses with basically condenses with the atmosphere or the moisture in the air when laser burned or laser cut or engraved, and then it condenses with the atmosphere, producing hydrochloric acid. And that hydrochloric acid will actually coat your laser machine and start melting the inside out over time. So that's what you got to be careful on. Next question. What lens is most commonly used for textile engraving? Great question. Most common is just a standard 2-inch lens. Nothing special about it because you can take it in and out of focus. It cuts and engraves beautifully. It is by far the most common lens for most applications, including textile engraving and cutting. Next question. Could the CO2 laser be used to weld polyester fabrics together, creating a strong bond? I haven't done a lot of work with this. When I've cut multiple layers together, it likes to bond together, but I don't know that you would call it strong. I'm able to typically tear it apart, so it's not strong enough to where it could be used in an actual product. But that's not saying that with a little bit more trial and error, maybe taking it out of focus, increasing the frequency to increase the heat, it couldn't potentially produce a strong enough bond based on whatever it is that you're using it for. So it's definitely worth some testing, I would say, and there is that possibility. Is it safe to cut fabric with fiberglass in it? I have done this, believe it or not, and it is safe. It's not going to hurt you or the laser system. The laser does like to refract off the fiberglass, and it can be troublesome and difficult to cut. And the edge quality is typically, it's not great. It's kind of a poor finish. And so, yes, it is safe. It's not going to hurt anything, but the quality is, it's not the best. So mechanical shears tend to produce a better effect. And so I would test it if you're not sure if it's good enough for you, depending on what you need it for. Okay, next question. Does the copper wire test for questionable materials work for knowing if the material contains PVC? I saw something last night about on like copper wire test. I'm not familiar with the copper wire test, whatever that is. Again, my suggestion for testing PVC is to try it in your laser the first time and be sure you know what it smells and looks like. Once you know, and then just don't do it again. Again, it's not harmful. I don't know what the copper test is. I'd have to do some research on what that is. So I apologize. Next question. What is polycarb that creates the problem in cutting? A little off topic. Polycarbonate is basically a polymer, but it's got carbon in it. And so when you go to laser cut it, it produces carbon, and that carbon dust interferes with the heat of the laser, producing a black, sooty, charred mess. It can be laser cut, but the edge is never going to look great. And so I typically don't recommend it. And if you do, and if you're don't really care about the edge quality, just know that it's going to be a black soot edge. I typically mask both sides and use air assist, and it can cut, but the quality is going to be poor. Thank you so much for watching this webinar and Third Thursday. Until next time, signing off.